Hello, hi everyone. This is Brodhraj Vishwakarma. All of you welcome on my YouTube channel. Our subject is power plant engineering. Topics is a regeneration in a ranking cycle. We already discussed about the ranking cycles in the last classes, but it was in a Nepali. Okay, if I get a free time, I will to explain the topics also in English. So this is a regeneration in a ranking cycle. This is the regeneration means this is the one kind of a method to improve the performance of a ranking cycle. How we can improve the performance of ranking cycle, how we can improve the efficiency of ranking cycle by the regeneration process. We can I'm going to explain one by one in this diagram, through this diagram. Okay, this is our block diagram and this is our TS diagram. Okay, by observing the TS diagram, we can get everything from this diagram. Okay, whatever the effects will occurs after the regeneration in a ranking cycle. Okay, let's discuss about this block diagram. Okay, all the calculations are based on the 1 kg of a fluid entering into the boiler. My dear, we are doing all the calculations on the basis of a 1 kg of a fluid entering into the boiler. So first I am going to explain some components. All of you know that's a boiler. It means that we are supplying the heat at a constant pressure, and this is a turbine. These are two turbines. Here the steam will expand. Okay, at a reversible process, adiabatic reversible process, and this is a condenser. As you know that here the heat will be rejected at a constant pressure, and this is a low low pressure pump. This is a P1, and this is a open feed water heater. Okay, so this is a high pressure pump. This is a pump 2. Now when 1 kg of steam, when 1 kg of a liquid or the 1 kg of steam is entering into the turbine 1, at this condition, so we are extracting the Y fraction of a mass of a steam from these turbines, and suppose if we are passing from 1 kg steam from here, means remaining how much we have remaining? 1 minus Y kg of steam is remaining. Okay, so this 1 minus Y kg of steam is expanding in these two turbines, right? In these turbines from here the expansion take place from 2 to 3. Now 2 to 3, many of have the confusion that we are writing 2 here and we are writing 2 also here. It means that, let me explain about this. I also had a doubt on this before. So here, suppose let this this is a 1 kg. Okay, this is a 1 kg. We are dividing this 1 kg of steam into two parts. Okay, suppose in this turbines we are extracting the Y fraction of steam from here, right? So suppose this is Y fraction of steam we are extracting. Now how much we have remaining? 1 minus Y. So in this case, the 2 point, this Y and 1 minus Y are at a same state. They are in a same state. They are at a same condition. They are at a same state too. They are at same state. So they are at the same state too. That's the reason we are writing 2 here and 2 here also. Okay, so 2 here and 2 here also. Okay, so now after expansion of 1 minus Y kg of steam here, then that 1 minus Y kg of steams are condensation at the condenser. Then as you know that what is the function of the condenser? The function of the condenser is rejection of the heat from the steam and convert it into the liquid. Then it transferred to the low pressure pump, and then it transfer 1 minus Y kg of steam liquid into the open feed water, and the Y and 1 minus Y are will be mixed here, the open feed water. Then we get it exit as a 1 kg as a resultant, as an exit value. Okay, then we are transferring this 1 kg of 1 kg of liquid into the high pressure pump, and then as you know that the function of a pump is maximize the pressure of a liquid and it transfer to the boiler. This is a general block diagram, right? So from this diagram we can draw the TS diagram, temperature and entropy diagram. In this diagram we are expanding. As you know that I already said you here 1 to 2, right? Here 1 to 2 there is a expansion take places. Okay, the entropy is constant, means the expansion is doing on the reversible adiabatic process, means 1 to 2 the expansion take place 1 kg of steam. Okay na, so 1 to 2 reversible expansion take place in a turbine 1 to 2 1 kg piston. At this point we are extracting from the state 2, from the point 2 we are extracting the y fraction of steam from this point. It means y fraction, how much you have remaining now, 1 minus y kg. Now from the point 2, okay now this is a very important, you have to understand on this point, from 2 to 3 1 minus y kg of steam is expansion take places here. In this turbine only 1 minus y kg of expansion take places, right, of steam expansion take places. Now 3 to 4, as you know that this is a turbine, this is a condenser. Here the 1 minus y kg of steam only condensate. Now 4 to 5, as you know that 4 to 5 means what, 4 to 5 means low pressure pump, right? It means the reversible adiabatic compression process will be take place here. The pressure will be developed, okay now the liquid pressure will be developed and transferred to the open feed water heater. Now at this point 5 and at this point 2 there is a constant pressure. The pressure at point 2 and the pressure at point 5 will always be constant. The same pressure will be there, same pressure at point 5 and at point 2. Now that's the reason the exit value, the 1 kg of steams also, the 1 kg of liquid lies between this constant pressure line. Okay now, so at this point, at the 6th point, the exit value lies at this 6th point. Now again what we are doing here, again we are passing the 1 kg of a fluid to the high pressure pump. This is a 6 to 7 watt, this is a 7, right? 6 to 7 we are again passing the 1 kg system to the pump. What you will do in this pump, the pump helps to increase the pressure of a liquid and supply to the boiler. Here 7 to 1 we are supplying the heat. We are supplying the heat, right? So what are the effect we will get, let's observe from the diagram. Let's compare the simple Rankine cycle diagram and a regeneration Rankine cycle. Okay, this is a regeneration Rankine cycle, my dear. Now let's delete it, remove it. Okay, now this is our, what are the effects we will get, okay now, after the regeneration process. Now here just I am going to draw the one simple Rankine cycle. Okay now, it will be helpful to understand the regeneration cycle and simple Rankine cycle, what are the effects we will get after the regeneration process, right? So okay, just wait, this is a simple Rankine cycle. As you know that this is a simple Rankine cycle TS diagram, right? This is 1, this is a turbine, 2, 3, this is a 4. This is our simple Rankine cycle. Look at my dear. Suppose in this case, suppose 1 kg of steam is entering into the turbine 1 to 2. We are here, the 1 kg, total 1 kg of steam is expanding at a one stage, right? 1 to 2. But in this case, look at here, 1 to 3. First, from 1 to 2, 1 kg of steam is expanded. Now from 2 to 3, 1 minus y kg of steam is expanded. Y means we are extracting the y fraction of steam from the point 2. It means that it reduces the work on the turbines. It reduces the work of the turbine. If you compare the simple Rankine cycle with the regeneration cycle, it means first 1 to 2, what, 1 kg of steam is expanded. From the point 2, we are extracting the y fraction of steam. Okay now, it means that remaining, how much we have remaining, 1 minus y kg of steam, right? So in this case, the turbine 2 to 3, the turbine work reduces. It means it reduces, turbine's work reduces. Now it means what are the effect we will get, right? Effect we get after the regeneration, what are the effect we will get, right? From the by comparing the diagram, this and this, we are getting the effect. The turbine work is, first point is the turbine work is reduces, right? This downward arrow denotes the decreases, upward indicates the increases, right? So now comparing, now come to the point 3 to 4. Here 2 to 3, right? This is 3 to 4. Now 3 to 4, what will happen in this cases? We are condensate, we are doing the condensations 1 minus y kg only. It means lesser than 1 kg. But in the simple Rankine cycle, we are doing the condensation 1 kg, full mass 1 kg of steam. It means that the mass is less, the load on the condenser is less than this simple Rankine cycle. It means that to the Q rejection also decreases. It means the load which we have to condensate in the condenser is 1 minus y kg only. Okay, that's the load on the condenser is less. It means that the Q rejection is less. Our next point, third point, we come to the point 4 to 5, right? In this case, heat supply, we are supplying the heat at a high temperature. We are supplying the heat from a high temperature. So the T main Q supply also what decreases. Q supply also decreases. If you compare this, the Q supply also decreases. It means decreases, right? Now coming to the point decreases. Now coming to the point T main temperature, it means that the T main temperature also increases. Why? Means we are increasing we are using the next pump also, right? We are using the 2 pump. It means that we are adding the temperature at a higher point, at a high temperature. We are supplying the heat at a high temperature, so the TM is increases. TM increases for next thing is, if the TM is increases, means as you know that efficiency also increases. Why? Means as you know that 1 minus TL by TM. This is our efficiency formula for the Rankine cycle. Okay na? So if TM is increases, the value will becomes less, TL will become less, and the efficiency increases. In this way, these are the effect we'll get in the regeneration process. Now some derivation are there for the calculating. How can you calculate the turbine work? How can you calculate the rejection, supply, Q supply? What other things will be there? I'm going to derive all this equation one by one. Okay. So first thing how can you calculate the turbine work? Look at here. Turbine work, right? Turbines from 1 to 2, for how mass is 1 kg, right? 1 into H1 minus H2 plus from 2 to 3, 1 minus y kg of steam is expanding from 2 to 3, S2 minus S3. This is the method, this is the formula. WT बराबर H1 minus S2 plus 1 minus y kg S2 minus S3. In this formula, we can calculate the value of the work done by turbines. Next things, Q rejection. We are doing the Q rejection from 3 to 4. It means 1 minus y S3 minus S4. Okay. So 3 topics, 3 numbers. Q supply, we are doing the supplying the heat from 7 to 1 process. It means that 1 kg, right? There is a 1 steam will be 1, mass will be 1 kg of fluid, and then it is S1 minus S7 into 1. Okay. So after this there will be the, after this I'm going to erase it. In this 5 to 6 phases, okay, I hope you will get it. this one balance condition will be in a block diagram. I think we have drawn this like this, right? Open, this is a 5 and this is a y. We are extracting the y from the turbine 1, y fraction of mass from turbine 1, and this is a 0.6. At the balance condition, at this balance condition, this is a 6, this is a 1 kg, this is 1 minus y. We already assume that in these cases in a Rankine cycle, we already assume the there is a negligence. We are neglecting here kinetic energy and potential energy, so we are only considering the enthalpy here. At the balance condition, this is S6, right? This is S6, this is S2, this is enthalpy. S means enthalpy, right? This is S2, this is S5. At this balance condition, y fraction of steam is entering and 1 minus y is entering here, no? So S6 into 1 equals to, it means that we are getting at exit we getting 1 kg. It means that y plus 1 minus y entering means what? We getting 1 kg, right? So S6 into 1, S5 into 1 minus y plus S2 into y. It means that S6 equals to 1 minus y H5 plus S2 y. If we are able to find out the value of y, we can find out anything. We can solve any problems related to the regeneration in a Rankine cycle. This topic is a very important, my dear. For the example, for any competitive exam point of view or any other exam, university exam point of view, each and every year they are asking on the questions, either numerical problems, either the derivation point of view, they are asking on the asking the question on the topics of this. Okay, it's a very important. If you have the good concept about the TS diagram and the block diagram, you can solve the problem easily on it. Okay, so as you know that efficiency means what? Efficiency, we all of you know that, we already know that efficiency means W net by Q supply, right? W net means W turbine minus WT minus W pump by Q supply. From here from here we can calculate the efficiency of the regeneration in a calculate the efficiency of the Rankine cycle. So this is all about the regeneration in a Rankine cycle. If you have any doubt regarding these topics, you can comment in the comment box. So this is comment section. Okay, so in the next classes we are going to start about the Brighton cycle. This is a gas turbine. After that we will study about the compressor, different types of a compressor. Okay, bye bye, take care all of you.